Hi, everyone, and welcome to another AIM Science with Dr. Karen Joseph. I am a science teacher at Deborah Bell's AIM Academy, and I'm here to do some more experiments with candy. We've had so much fun the last couple of weeks doing candy experiments, and we could do candy experiments forever because there's so many different kinds of candy, but thought it might be fun to do one more series of experiments. So we're going to start out today with a candy acid test. And to do this experiment, we're going to need some kinds of sour candy, some warm water, some baking soda, and some cups or bowls or glasses that are clear that you can see through. So we're going to use for this experiment extreme sour warheads, lemon heads, Sour Patch Kids, and Sweet Tarts. These are all different kinds of sour candy. And let me move this bowl, this plate full of dishes in here so that you can see what we're going to be doing. So what I'm going to do is I've got 4 different kinds of candy, so I have 4 different glasses that I'm going to use here. And I'm just going to pour some candy down in the bottom. Now these are all sour candy. That means that they've got something on them or in them that makes them sour. And that something is a kind of acid. A very weak acid, very similar, oh, that one's in a bag. Very similar to the kind of acid that is in vinegar. And if you were here and you remember when we did the vinegar experiments before, when we mixed vinegar and baking soda, we got a really fun reaction. So you can see here all the different kinds of candy that we have. We have Sweet Tarts in the first one. We have the Sour Patch Kids in the second one. We have Lemon Heads in the third. And then in the fourth, I'm going to put some of those super sour warheads. And I'm going to move these boxes and bags out of the way so you can see the entire experiment. So what we're going to do first is we're going to put some warm water in to completely cover, a little bit more than cover, so that the candy, so that we can dissolve away the acid. Now, different kinds of candy are made differently. So, for instance, the Sweet Tarts have the acid all the way through, while the Sour Patch Kids have an acid powder on the outside of it. And what we want to do is we want to dissolve that acid. So we're just going to allow them to sit in the water for a minute or two here. I'll move them back so that you can see them. I'm going to swirl the glasses a little bit just to facilitate the dissolving process. We learned about dissolving last time when we learned that what happens is those water molecules have positive and negative ends to them, and they pull on the positive or negative ends of the candy. So now we've got a little bit of dissolving going on there. A little bit of the acid has dissolved off of the candies. So now we can go ahead with our experiment. So we're going to use regular baking soda, and we've dissolved some of the acid. So what do you think is going to happen when we mix a little bit of baking soda, which is a base, with the acid that came off the sour candy? So let's start out here with the Sweet Tarts. We're just going to use a spoonful of baking soda and put it right in and watch what happens. Can you see that dissolving, the bubbling that's happening? I'm going to raise that up and hold it up a little bit closer so you can see the bubbles that are coming off of the candies. So much so that they're even causing some of the candies to lift up a little bit. So we've got that acid-base reaction happening here. Let's try it again with the next candy, which is the Sour Patch Kids. Again, just about a spoonful. Pour it in. Ooh, that one's even more. That's really fizzing. Awesome. Now let's do a little bit with the Lemon Heads. Not quite the same reaction, is it, with the Lemon Heads? But what do you think is going to happen with the super sour warheads? Let's try that and see. Oh, I hope you could hear that. Let me bring that closer. You can see and hear that's really a very strong reaction. In fact, the reaction with the warheads is so strong that if I just take this little beaker that I have here that has the dissolved baking soda in it, watch what happens when I just drop a warhead in without even doing any dissolving. Look at all those bubbles. So do you remember what happens? We talked about this before. So when you've got an acid, like the acid that's in the candy, that comes into contact with a base like the baking soda, we have two different kinds of reactions happen. So the first reaction creates a salt that is called sodium acetate and another chemical called carbonic acid. But carbonic acid is not very stable, so it breaks down very quickly in a decomposition reaction that makes carbon dioxide and water. So the end products that we have from an acid-base reaction are that salt and then carbon dioxide and water. But carbon dioxide doesn't mix with water, so it bubbles up and it goes to the top of the surface of the water where it's released. Now, I want you guys to look. I don't know if you can still see that, but we have still got bubbles coming up from all these different kinds of candy. If you're able to do these experiments at home, you'll really be able to see. And even though the lemon heads didn't give us much of a reaction when we first dropped it in, there's a lot of bubbling that's taking place now as we allow that baking soda to continue to come into contact with the dissolving acid from the candies. All four of those are dissolving and causing that acid-base reaction. So there's a couple ways that you can extend this experiment. One thing you can do is you can compare them with different kinds of candy and see which happens first, which gives you more of a reaction. You could try different colors of candy. Do the blue sweet tarts give you more of a reaction, or maybe the orange sweet tarts give you more of a reaction? Those are all different ways that you can extend the experiment. So the next experiment we're going to do actually uses a microwave. We're going to take a microwave oven and we're going to put some Peeps in it. Peeps are kind of marshmallow candy, and we're going to microwave the Peeps and see what happens. But since my microwave is upstairs in my kitchen and my computer's downstairs in my family room, I needed to record this experiment ahead of time. So I'm going to show you the video of this experiment happening. Now, what you're going to need in order to do this experiment is a microwave safe plate, some Peeps, and an adult helper. The reason you need the adult helper is because when the Peeps go into the microwave, they get very, very hot. So I'm going to turn the camera around now so that you'll be able to see the experiment in action, even though I had to record it before. I put this black cat-shaped Peep in the center of a large microwave-safe plate, and I put it in the microwave. Then I turned the microwave on high and microwaved it for about 30 seconds, watching as the Peep changed shape right before my eyes. Peeps are marshmallows that have been covered in sugar and formed into fun shapes. Marshmallows are made of gelatin and sugar syrup that's had air pumped into it, creating little pockets of air that are filled with oxygen, water, and other molecules. So when they're microwaved, as you can see here, the water molecules inside the air pockets heats up and turns into steam, causing the air pockets to expand. The sugar and gelatin stretch around the expanding air pockets, and the Peep gets larger. It also gets hot. Now, look what happens when we stop the microwaving process. Once we took the Peep out of the microwave, or just turned the microwave off, it collapsed and shrank down. But it did not go back to its original shape, because as the gelatin got hot, it melted and lost its structure. Now, Peeps are safe to eat, but they're not going to taste the same after microwaving. Since water was lost, it's a lot tougher and might be a little bit crunchy and hard. No series of candy experiments is complete without the classic experiment with Diet Coke and Mentos. For this experiment, I also needed to record it because I had to do this one outside. You'll see why when you take a look at the experiment. So in order to do this experiment, you need a package of Mentos. You need a 2-liter bottle of Diet Coke. You might want to buy a couple because this is so much fun that you're going to want to do it a couple times. And then you need a way to get the Mentos into the Coke. So you can either use a rolled up tube of paper, or you can purchase online or at some stores a special kind of a tool that allows you to drop the Mentos in the Coke all at once. So let's take a look and see how this experiment worked. For this experiment, we're using Diet Coke and Mentos. Mentos is a minty kind of candy that has a lot of bits on the outside of it. And that'll be important when we explain why this works. I have a special kind of tool here that helps to get the Mentos in all at the same time. You can also do this in different ways by using some paper, rolling up a tube, and then dropping them in. But the little tool that I have makes it work really nicely. So I'm going to get ready, and I've got my my raincoat on here so that I'm sure that I'll stay a little bit dry, but I'm going to have to be ready to run. So I'm going to pull this back. The Mentos are going to drop into the Diet Coke, and then I'm going to run. Are you ready? 1, 2, 3. How cool is that? All right, let's do that one more time. Okay, I have another bottle of Diet Coke. I have 3 more Mentos, and I have a different kind of top this time. This one has 3 little holes in it. So we'll see if we get a different reaction from the 3 little holes than we got from the 1 big hole with the last bottle. All right, I'm going to get ready. 1, 2, 3. Well, that was a lot of fun. Should we try one more? All right, let's do it. So I was wondering, after we did the last one with 3 Mentos, if we might get a better reaction with 6 Mentos. So what's your hypothesis? Do you think we'll have a better reaction with 6 than we did with 3? Let's give it a try. On your mark, get set, go. We did. We definitely got a higher fizzing effect with 6 Mentos than we did with 3. Awesome. So let's talk about what happened in the Diet Coke and Mentos experiment. First of all, why did we use Diet Coke and not regular Coke? Well, this actually would work if you used regular Coke in exactly the same way. But regular Coke has sugar in it, so it would make a really sticky mess. The Diet Coke's a lot easier to clean up, so that's why this experiment usually uses Diet. And you can try any kind of soda. It doesn't have to be Coke. It could even be a generic brand of soda. You might want to give it a try with different kinds and see what kind of reaction you find works best. So soda is all carbonated, which means that it has invisible carbon dioxide gas dissolved in it. This carbon dioxide gas can come out of the soda pretty easily, which you've noticed if you've ever opened a can of soda and had it spray all over you. And when the carbon dioxide comes out of the solution, it often takes the liquid soda with it. That's what makes the spray come out when you open a can of soda that's been shaken. So Mentos candies have tiny pits all over the outside surface of them, and those pits act as what we call nucleation sites. Those are perfect places for carbon dioxide bubbles to form. Mentos are also heavy, so when we drop them in, they sink all the way to the bottom of the Coke, so we're able to have a lot of surface area to react with the soda. So as soon as the Mentos come into contact with the soda, bubbles of carbon dioxide form on those nucleation sites, and they quickly rise to the surface of the liquid and squirt out through the hole in the top of the cap, taking the liquid soda with it. And that's why we get that fun reaction when we put Mentos into diet soda. So that's all I have for today. I hope you enjoyed these experiments, and I really hope that you'll try them at home.